Okay, Chapter 3, Lesson 5, Part 2, Parallel and Perpendicular Lines. Remember the correlation of perpendicular lines and their slopes? Perpendicular lines have slopes that are opposite sign and reciprocal, which means flip fraction. So in this first example, find the slope of a line that is perpendicular to y equals 2x plus 4. So all I'm concerned about is the slope. And so for the slope, I need to first do opposite sign. So instead of positive, I'm going to have a negative. And the reciprocal or the flip fraction of 2 is 1/2. Remember that parallel lines have the same slopes. So I look at the same example. My slope is 2. So on a parallel line, my slope would also be 2 because I don't want them to cross. I can write the equation of a line parallel or perpendicular to a given line and through a given point. So basically what's going to happen here is they're going to give us the graph of a line, and then they're going to say, find the equation of a line that is parallel to this line, but goes through that point. Or they're going to give us the line, and they're going to say, find a line that is perpendicular to that line that goes through this certain point. So the first thing we should do is find the original slope of the red line. Obviously, your equation must be in slope-intercept form, which is y equals mx plus b. And then ask yourself, are they looking for the parallel or are they looking for the perpendicular slope? Once you've got that figured out, we're going to use the point slope form from yesterday, the y equals y minus y1 equals m parentheses x minus x1. Then distribute, and then add or subtract to get y by itself, like we did on yesterday's lesson. So here's the example. Write the equation of a line that is parallel to, and I'm going to draw a picture of this original one. So it starts at -2 and it goes up 3, right 1. So here's my original line. And it wants the equation of a line that is parallel to that, but going through the point 6, 1. So they want the equation of the purple line. So the first thing I have to do, according to my notes, is take the slope from the red line. It's 3. And determine if you want parallel or perpendicular. Well, the direction said parallel, so I'm also going to use slope as 3. Here's my point for the purple line. And so I just start with y minus 1 equals 3 parentheses x minus 6. Distribute on the right to get 3x minus 18. Add 1 to get 3x minus 17. And if you look, this one is going down really fast, and so it's probably going to end up crossing at -17. And the slope of the red line and the purple line are the same, and so I know they are parallel. Another example here. In this problem, we do not have our slope because it's not in slope form. So before I can even start, I have to subtract 3x to both sides. So that gives me -1y equals -3x plus 9. Divide everything by -1, which gives me positive 3x minus 9. So my slope of my original line is 3. I want a parallel line, so I'm going to keep the slope as 3. Here's the point I'm given. So for my new line, I'm going to do y minus 1, bad color choice, y minus 1 equals 3 parentheses x minus -2. Distribute to give me 3x plus 6. Add 1 to give me 3x plus 7. So this line here and this line here are parallel. Now we're working on lines that are perpendicular. So if my original line is y equals 3x minus 2, and I want a perpendicular line through the point 6, 1. So I want it to go like that to be perpendicular. My slope this time is going to be, because of perpendicular, opposite sign. So that one is a positive 3, so I'm going to make this a negative, and reciprocal, which is 1/3. Here's my point. So y minus 1 equals negative 1/3 x minus 6. Y minus 1 equals negative 1/3 x plus 2. Y equals negative 1/3 x plus 3. Write the equation of a line that is perpendicular to this first equation, which is not in y equals. So I'm going to subtract 2x to both sides. So my slope on this line is actually negative 2. So my slope for a perpendicular line is going to be positive half. So y minus 0 equals positive half, parenthesis x minus 3. Y minus 0 just becomes y. And when I distribute, I get 1/2 x minus 3/2. So this line and this line are perpendicular.